Hello and welcome to chapter 26 of this Flutter course. In the previous chapter, you saw that we started using our auth service in our user interface code. So we're not going against Firebase directly. So we removed all the imports to Firebase in our user interface files in the login register, main Dart file, and notes view, and also verify email view. And we have a good working auth service. However, what we're missing are some tests, and tests are one of my absolute favorite topics when I talk about software development because they make your code a lot more robust than just writing the code and leaving it in there. And I understand some software developers may look at things as black and white, saying that you have to have codes or you don't have to have codes. But I'm more of a grayish person in thinking that, well, you have to be realistic. Sometimes if you're, for instance, writing an application for yourself in a hackathon, for instance, and in you're in time pressure and you just want to get something out, well, that's not the right place to write unit tests if you're in a hackathon. But if you're working with a company and you're getting paid to write good software, and you're getting paid to write your tests as well to make sure everything's working out as it should, especially if you're a back-end developer or software like a front-end developer, then you will need to ensure that your code is tested properly. So I'm going to bring up the caption here about why we actually need tests, and especially unit tests. And we're going to talk about the different types of tests in a while, but let's just talk about unit tests. I mentioned in the like the outro to the previous chapter about what unit tests are and why we need them. And for me, the main reason having a unit test is to ensure that if you think here's the auth provider, we left it in a state that, well, it's working, okay, quote unquote working. So it's working, but what if a new developer comes into the project and tries to change some code so that it works for her or for him, but unintentionally changes the code so that it's not working for us the way that we intended it. So that's one of the reasons we have unit tests. Okay. So that's what we're going to do in this chapter. And I completely understand that if you're watching this course, you're probably sitting somewhere in a calm area, calm room, and you're watching this course yourself. I think the chances of you watching this course with a group of people are quite slim. So, and chances are you're just following along with the course and you're trying to write an application and release it to the App Store or Play Store. So maybe you're not so interested in making sure that your auth service is actually tested, and I completely understand that. But I'm basically designing this course for people who are trying to become also good software developers. So if you're coming, as I've mentioned, like one of the personas that I developed this course for are designers. So if you're a designer, have no background in Flutter development, you may also be interested in writing tests for your application, especially if your goal is to go into a bigger organization and actually get a job as a Flutter developer or as a software developer. So given that background, you should know what tests are, what unit tests are, integration tests are, and what, for instance, widget tests are in Flutter. Now, I need to also mention that there's something called a TDD, or test-driven development. And the right way of actually doing test-driven development is to first write the tests and then you write your software. At the moment, we're doing it the exact opposite because I didn't want to complicate things as we're going, because as I said, I've designed this course for someone who's probably new to Flutter development or software development in general. So like going into test-driven development directly and then writing our auth service probably would have complicated things more. So for the sake of simplicity, we wrote the code and then we're writing the tests. But just so you know, if you hear people talking about TDD, test-driven development, what they mean is that you write the tests, and in the writing of the tests, you come towards the conclusion of how the interface of the class you're actually writing the tests for should look like if you're working with classes. So test-driven development is there. It's very important, and we should be aware of it, how to use it. And if you're working in a software development organization, you should do driven development if time allows, and if all the constraints are in the right place for you to actually do tests. And as I said, I look at things more like not in a black and white vision, more like a gray vision. I say that you should do tests, but that is, again, something that is completely up to you and up to the situation that you're in. So just be aware of what TDD is, and that the right way of doing test-driven development is that you first write your tests, and then you write the interfaces and the code that the tests are actually performing their tests on. There's lots and lots of resources online about TDD and what it actually means, how it should be used, TDD Flutter as well. So I strongly suggest that you have a look at those resources as well. And maybe perhaps after you've gone through this chapter and gotten like the basics of doing tests. Now, you see, we have time limit in this course because this course can't go on for hundreds and hundreds of hours. First, because I wouldn't probably be able to put so much time. I know that this course is already going to go over 20 hours of time, but it is going to take a lot of time if you want to go and cover everything and all different types of testing in Flutter. So for the sake of simplicity and making sure that you follow along with this course without dropping off and getting scared of all testing things that we're going to do, I'm going to give you like the basics, and I'm going to give you the building blocks that you need in order to be able to carry on later on your own and write more and more tests. So just know that the reason we're dedicating this chapter to testing is to make sure that everybody understands that testing is very important, but also we are not going to have many hours just to focus on testing, though it is a very important subject. Now let's talk about different types of tests. I mentioned this in the outro to the previous chapter, but I'll mention it here in case you've jumped over that chapter, which I don't recommend. If you talk about different types of tests in Flutter, you should know that there are unit tests, widget tests, and integration tests. And let's just quickly talk about what these different types of tests are. Well, let's go and talk about the concept, for instance, of a class. Let's say you've created a class called AuthService, which is the case for us, and you want to write some tests for this class. Now, this class is very isolated in its own. Like it has a set of functions, and it has a getter called current user. If you don't remember that, let me just bring it to the screen so you see better. So let's go to our AuthService. And you can see it conforms to and implements the auth provider. It has a constructor, it has a factory constructor here as well, and it has all the functionalities that are provided by the auth provider because it implements auth provider. So I'm going to actually increase the size so you see better. So this is a unit of itself. So it's an isolated piece of code that talks with an auth provider and then gives us basically it mirrors the functionalities of that auth provider, which in this case is in the Firebase case is the Firebase auth provider. So it doesn't have so much functionality, but it has functionality good enough in order for it to be tested. And it's actually important to test it just to make sure nobody unintentionally changes this code without consulting with us or without and making sure that their changes aren't going to break our code. So that's unit tests. So you have a unit of code, you have a piece of code isolated, and you want to test that piece of code and to ensure the different functions inside that code are working as they should. So that's just like a general idea of what a unit test is. Now, a widget test, as its name indicates, is a way for you as a software developer is a way for you as a software developer to make sure that your widgets, like the UI that you're creating, is working as it should. For instance, if you have a login view in your application, and this login view allows the user to tap on a button in order to log in, and you're saying that, okay, in the UI, I'm going to make sure as soon as you press the login button, until the user is logged in, that this login button should be disabled. Okay, so that's a piece of logic that you thought about. Good idea. You put that code in there, but how do you test it? How do you make sure that the login button stays disabled until login is successful? that's where widget testing comes into play. So widget testing is some sort of like an end-to-end test. And by that, we mean that your widgets are probably talking with your services and with your providers. So your widget, for instance, the login widget or the login screen, upon pressing the login button, is going to call into your service, in this case, the auth service, and it's going to go into this login function. This login function in turn is going to talk with a provider. The provider in turn is going to talk with the Firebase code, which in turn is going to talk with the Firebase backend. So you see the layers are stacking up. UI is here. The button is on the UI. UI is talking with auth service. Here, auth service is talking with the provider. The provider is talking with Firebase. Firebase is talking with the Firebase backend, and maybe the backend is also talking with some other services. So that's end to end. It's one end, and the other end is right here. So you are basically, by writing widget tests, you're doing end-to-end testing in a way. Okay, so that's widget tests. The other things are integration tests. You see, an integration test is where you, for instance, have a service, which we have in this case, the auth service. And the auth service is, in this case, the auth service constructor or the factory constructor is talking with Firebase. So if you test our auth service the exact way it is, in that you go and say auth service Firebase, and then you issue commands against this auth service Firebase. You create a user, you sign in with a user, you log out, you send an email verification. If you're doing these tests, you're actually doing integration tests. So because you're making sure that the code is also working end to end, but there's no UI involved. So, but you're now thinking, okay, if testing auth service the way it is integration tests, how come you said in the beginning of this chapter that we're going to do unit tests? And that's what we need to talk about now, because you see, in this unit test exercise that we're going to do in this chapter, we're not actually going to call Firebase. We're going to do something called mocking. I don't know if I've actually mentioned something here. Yes, I can see that later. I'm actually going to talk about mocking. And mocking in English, it could mean you're making fun of someone. And that's not this, what we're talking about here. Mocking is kind of like you imitating a real service. So imagine you have the auth service. The auth service has a Firebase factory, talks with Firebase, and in turn talks with the Firebase code, and then talks to the backend. We're going to get rid of all of that pipeline and say we're going to test the auth service, but we're going to give it another provider, a provider that we control. You see, the Firebase auth provider has a lot of code in it, so we can go in there. Let's go in the Firebase auth provider. It talks directly with Firebase. But what if we could create an auth provider that conforms to auth provider, and then write a lot of logic in that auth provider and provide that auth provider to the auth service? Now, all of a sudden, we have an auth service that delegates all its tasks to this mock auth provider that we control the code for. So we know exactly what the sign-in is going to do. We know exactly what the sign-out is going to do, or login and logout, depending on the terminology that you like to use. So what we're going to do in this chapter is mocking, and I'm going to explain that soon. So let's just jump over that for now. Okay. The next thing that we need to talk about are dev dependencies. If you're coming from like a Node background, if you work with Node.js or Express, you know already about NPM, which is the Node package manager, and you know what dev dependencies are in there. If you're coming from an iOS background, there isn't much of a dev dependency, to be honest with you, except if you're coming from an iOS development background, then you know when you're writing your tests, those test frameworks, etc., that you bring into your test target, they're inside their own target so that they're not shipped with the final product. If you're not coming from any of those backgrounds and you just want to know what dev dependencies are, I'll explain it now. You see, when we're working with our application, if we go to our PubSpec YAML, you'll see that we have a section here called dependencies. And at the moment, we have dependencies on various libraries. For instance, Firebase Core, Firebase Auth, Cloud Firestore, and Firebase Analytics. These are the dependencies or libraries that we're bringing into our application which, if you think this is our application, these are the various libraries coming in, and then we're at the end, at the end of this course, we're going to send our application to App Store and Google Play Store. When we create our application to send to these respective stores, we're bundling the application and all the dependencies together and sending this as a complete binary to the respective app store. However, you also have a section here in your PubSpec YAML called dev dependencies. Now, dev dependencies are dependencies that you use and bring into your application only during the development of your application, meaning that when you ship your application, which is a term used for saying that when you create the application and post it to the respective app store, for instance, for review, then those dependencies aren't actually packaged inside your application. So they're only inside your application while you're developing it. And as soon as you package it up and send it for release, then those dependencies are not going to be packed inside the application. All right. So those are dev dependencies. Now let's go to our testing here. So as you can see here, we need to bring tests into our Flutter application to make sure that we can actually run our tests. So you will see here Flutter test is already included. I'm going to show you the command that you'll need to issue in terminal in order to bring it manually as well. And that is, if we go in here and just type Flutter pop add test dev. All right. It's doing a pop get there. Okay, this job is done now. Now let's have a look in here. And you can see now we have a dev dependency called test. And that's how you bring it into your application using this command. So I'm going to bring it up again, just so you see it. Flutter pop add test and a dash dev. As I said, if you're a Node.js developer, you'll know this from npm-d, which adds it as a development requirement or dependency to your application. So I'm not going to assume that you've brought in this test package into your application with the command that I provided here for you in the terminal. So if then you look at your PubSpec YAML file, so I'm going to bring this down. If you look at your PubSpec YAML file inside dev dependency, then you should have this test package only inside your dev dependencies. If you see that it is brought into the dependency section that is incorrect, it shouldn't be there. And that is because you've missed perhaps adding the dash dev at the end of your Flutter pop add test command. So if you do it like this, then test is going to be added to dependencies, and that's incorrect. So make sure that you fix that error. Okay, so let's go to the next section and talk about that now. If you bring up your Explorer, you will notice that if you go to your test folder, the entire test folder at the moment is marked as red. Actually, it's not marked as red like an email. It's is rendered in red color. That's what I mean. So it could be maybe heard in the wrong tone. So if you go in there, that folder was red. And then if you click on this file, which is called a widget test, that file is also red. It has a lot of errors here. Actually, no, it has one error because it's creating something called a my app. So what we need to do in here, because we don't need this existing test. You see, this test was created for us when we created our Flutter application. We need to get rid of it. Okay, so let's go in here and right click on it and just say delete, and that file is gone. Okay, so that's the first thing that we had to do. Collapse this lib folder here as well. Now what we need to do here, as the caption indicates, we need to create a new file called auth-test.dart. Okay, so let's go ahead and do that under the test folder. So let me go ahead and do that right now. Under the test folder, right click and say new file, and then call it auth-test.dart. All right. Okay, and what we need to do then in this auth-test.dart right now, this function is completely empty. So let's first add a main function in here. like that. And you can see as soon as you add the main function in here, Dart is intelligent enough to give us a run and a debug functionality here. And that's displayed in Visual Studio Code. I think Android Studio also does the same thing. I don't think Vim is able to do that. It may be. Vim is time and time again has surprised me with all its amazing capabilities. But depending on the tool or the text editor or the IDE that you're using, this could be different. But don't worry about it. We're not actually going to click on these things. So if you don't see these things in your text editor, you don't have to worry about that. So now that we've done adding the test package, now that we've imported test package as dev dependency, we also need to import it. So let's go in here and say import. Get rid of this editor, Explorer on the left hand side, and I'm going to say if we import a package called test, and there's a file in there called test start. So now we're ready basically. Okay, all right. Now you see, you may not have noticed it, but I have this application already running on my actual Android phone, as we've done in the previous chapter. So I never kill this application without a reason. It's always running on that Android phone. I can always bring it up with strcpy, so I can see right here that is running without a problem. However, remember one of the first previous chapters, when we talked about adding Firebase to our application, I think it was chapter 5 or 6. It was very early in the course. When we brought in Firebase, we needed to kill the application, meaning that we needed to terminate the application and run it from scratch. So depending on some dependent, actually, no, I don't think it's depending. When you bring in a new dependency in your project, you need to always ensure that you rebuild your project. So you cannot do hot reload and hot restart, because some of these dependencies, they actually need your application to be compiled from scratch and then be brought into your binary. So hot reload and hot restart aren't going to actually be able to bring those dependencies yet, at least, into your Flutter application. So what I need you to do is to stop the execution of your program, and then let's go in here, save these changes. Then let's go and say main.dart, and let's run the application without debugging. And let's see if this is going to launch the application correctly on the right device as well. And I can see, yes, it is going to run it on the correct device. I'm going to change the screen layout a little bit here as well. So let's just then wait for this Gradle build to finish doing its work. It might take some time depending on the changes that you've made to the application. In this case, we brought in a whole new package called Test into our application. So it is taking its time, and that's completely fine. And I can see now it has run our code without a problem. Great stuff. For this chapter, I don't think we need our device with strcpy. If you're using iOS simulator, I don't think you need it. If you're using an emulator, I don't think you need it either. So we could just get rid of it, so we don't have to display it on the screen. But remember, my application is still running. Okay, so let me get rid of this here. Get rid of the widget inspector, get rid of the main Dart, and let's go to our auth test Dart file in here. Okay. Now, one thing that we also need to fix before we start writing our tests is this little functionality here, this little guy in our auth user. If I bring up auth user here, you'll see that it has the way we left it is we added a member variable to this auth user immutable class here called is email verified. And the way we're constructing this auth user, if you see here, we're saying auth user, just give us this boolean. So if from anywhere inside your function you have if from anywhere inside your application you want to create an instance of auth user, you'll probably do like this auth user, and then you have to pass a boolean is email verified. However, you'll see that parameter has no name. It's just a true or false. If I as a programmer see auth user true, auth user false, I don't understand what this true or false is. What does that even mean? Does that mean the auth user is turned on? Is turned off? What does it mean? For that, Dart has the capability to give you required named parameters. And that means that instead of passing true in here, you will be forced to write auth user is email verified true or false, like that. So in order to do that, as the caption indicates, we need to go and make this a required parameter. And the way to do that is to wrap it inside curly brackets like this, and then prefix it with the word or the keyword required. So after you've done that, this function is not going to work anymore because this parameter is missing. So is email verified? And we're going to pass this value right there. Okay, and let's just remove that function. So now we've achieved what we said we're going to do. Now, because you see, we're not actually, you may think that, okay, we've changed this parameter to required. So where are all the errors in our code? Why didn't anything break? And that's one of the beauties of what we've done so far, in that we've abstracted away so much code that the code is a lot more robust now. So because nowhere inside our application we're actually creating auth users except from this factory function. And the only place we had to fix this is email verified is inside this factory function. So to me, that's beautiful, because doing something like drastic by adding a required parameter to a class, it didn't break anything. So we're just good to go. Okay. All right. Now, this is the point that I mentioned previously, that we need a mock auth provider. All right. In order to do a mock auth provider, I need to go a little bit more into what mocks are and why we need them. You see, in software, we have, especially in testing as well, or even as the app architecture level or software architecture level, we have something called dependency injection. Dependency injection, just quickly explaining it, is very similar to our auth service. Let's have a look at our auth service here. You see, auth service is dependent on an auth provider. And it's not just making the assumption that its auth provider is always Firebase. It provides a factory for Firebase, but it's not making an assumption about that, hey, I'm always locked to Firebase auth provider. This is dependency injection. So this auth service is dependent on a provider. Using a constant constructor or initializer, we're injecting the provider into it. This, in a nutshell, is dependency injection in software development. You could go into a lot more details about it, but we don't have time for it. So what is a mock? The mock goes very, very well hand in hand with dependency injection, in that, in this case, you can see we have an auth service that is mirroring the functionality of its provider, which you could inject into it. But the provider that we're using at the moment is called Firebase. What if we created a completely new provider that we have complete control over? We can make sure that it conforms and implements auth provider, and we can make sure that it implements all those functionalities that auth provider implements and overrides all those. But we have some special logic in our own mock auth provider. Then we will give this auth provider to our auth service, and then let the auth service do its magic and mirror all those functionalities of the provider. So we're going to mock an auth provider and provide that into our auth service. So that's what mocking is. When you create a new function or a class, and then you can then inject that into another place and then test that another place. Okay. So let's go in our auth test Dart file that we have right here. I'm going to Command S on it, and let's go and create our little auth, like mock auth provider. So I'm going to go in here and I'm just going to say class mock auth provider, and suggest you do the same thing. And this guy is going to implement the auth provider. And auto import it for us. Okay, so like that. All right. Now what we need to do is just to get mock auth provider to implement all the functionalities that the auth provider abstract class requires us to implement. So I'm going to Command dot on it and respectfully ask Visual Studio Code to create those 6 missing overrides. Thank you so much, Visual Studio Code, for making our lives easier. Okay, now what we need to do is just to do the heavy lifting of this mock auth provider, which means to go ahead and create the functionality for the auth provider. Okay, I understand that the code is completely ginormous right now, so I'm going to decrease the size a little bit so you see more of the code. So let's go ahead and take care of the first function in here, which is create user. Okay. Now you see, what we're going to do is, if you remember, our auth provider has a function called initialize. All right. Now, when we're using auth provider in the context of Firebase, Firebase internally has the concept of whether it is initialized or not. But when we're creating a mock auth provider, where is that functionality? We don't keep track yet of whether our mock auth provider is actually initialized or not. And we just have an initialize function, but what if someone calls create user on our mock auth provider without having initialized the provider yet? And that's what we need to do now. So let's go ahead and keep track of that. So what we're going to do here is we're just going to say var is initialized is false to begin with. Okay. And the reason I'm saying underscore is initialized is because this is making this property pretty much private to our mock auth provider. So we're indicating to the outside world that, hey, you shouldn't be reading from this property or writing to this property. Okay, that is done. Now let's create a little getter for this property so that when we're testing our mock auth provider, we can actually say, hey, are you initialized? And we can also create a test for a mock auth provider, which we're actually going to do is to say, okay, when we create the mock auth provider, it shouldn't initially be initialized. However, after calling initialize on it, then we make a test to make sure that initialize flag is set to true. So in order to do that, we need to be able to read this is initialized flag. Let's go ahead and create a Boolean getter for it. We call it is initialized. Is initialized, and we just return is initialized in there. All right. Now let's go into our create user. I'm going to put a comma at the end of that parameter. And I'm also going to take the liberty of going and putting a comma at the end of login function. And that's the only 2 places that required a comma at the end of their parameter list. So now Dart formatter is able to format the code a lot better. Okay, let's go to create user. Now you see in create user and pretty much in all these functions that we're writing in here, for instance, login, send, email verification, we need to make sure that this mock auth provider is already initialized. So we're actually going to throw an exception if you call these functions that require initialization without having initialized the mock auth provider first. So let's go and define an exception in here. So let me see actually if I have written that down somewhere. Nope. So let's go in here and just say class not initialized exception implements exception. So you should know this from before, and it's empty for now. Okay. So what we need to do in here, we need to just say if is initialized. If it's not initialized, then throw not initialized exception. Okay. So that's an if statement. It's a one-liner. That's why we don't need a curly bracket in here. Otherwise, you'd put curly brackets in here and then do the throwing in there. But you could also use a one-liner if statement if that's what you're doing, just one line of code. All right. And I kind of like these one-liner if statements, to be honest with you. So I hope you got this. If the mock auth provider is not initialized, throw that particular exception. Then what we're going to do is we're going to fake creating a user. Okay, so we're just going to say, if you call the create user on Firebase, for instance, it probably needs to go and talk with Firebase backend. So it's going to take some time. So let's build in some little delay in here. And what we're going to do is just to say future and delayed. And here you have to pass a duration to it. So we say const duration, seconds, and we'll say 2. I believe that's it. Let's just say 1 in here. And remember, future delayed. If I go and move over its function signature, it returns a future of dynamic. So by creating a future, you're not actually waiting on it. So let's mark our function as async and let's just wait on it. Okay. Now, what we do then is to make sure that this create user actually returns an auth user. But remember, also in Firebase, or I don't actually know if Firebase works like this, but by creating a user, what we're going to do in our mock auth provider is actually logging that user in as well. Okay, so let's just say you see login returns also a future of auth user. So at the end of this create user, we're just going to make our lives easier and just return the result of logging in. So let's just say return login this email and password. Okay. So this is a very dumb and very easy mock implementation of create user. In itself, it does 3 things. Checks to make sure that you're initialized, and if you're not initialized, it throws an exception. It does a mock 1 second wait just to like fake making an API call. And the third thing that it does is that it calls a login function with the same email and password and returns the result of login just so that it can get its auth user. Okay, now we need the mock current user. So how do we do that? How do we get a current user? You see, Firebase has the ability to keep track of the current user, but how do we do that? We can't just go and delegate this functionality to Firebase right now. So we also need to create an auth user in here. Okay, so let's go to your mock auth provider right there. Above is initialized or below it, doesn't matter, somewhere. I'm going to do it above. I'm going to say user like this. That you see in Dart, if you make a member variable optional, by default it is null. So it has no value. So you don't have to actually go and say null. And you can see it says don't explicitly initialize variables to null. Good analyzer. Now that we have a user that we're internally going to manage, and I'm actually going to make it prefix it with an underscore so that it is marked as a private function, as a private member variable. Then in the current user, simply return that user. So like this. Okay. Perfect. Now we need to go and take care of the initialize function. Let's see if we can find it. Login here is initialize. So the only thing we're going to do in initializer is we're going to fake waiting, just wait for like a second, and then set our is initialize flag to true. So let's grab this code of await from our create user function and then bring it to initialize, and then just say await and make your function asynchronous. And then we're going to just await, and then we're just going to say is initialized is true. So that was an easy one. All right. So then the meatiest part of our mock auth provider is actually the login function, because it's not that it's doing login, but it's also the function that the register function is using. Or do we say create user? Create user. So that function is also logging it's calling the login function. So we need to really test this function to ensure that it's working properly. Okay. As I mentioned before, in most of these functions, we need to make sure that our mock auth providers initialize before these functions are called on them. So let's go and grab this code. You see, it says if is initialized, and bring that code as well in our login function. So that's the first thing that we're going to do. Now, we're also going to build in some fake functionality into the login function just so we can write tests for them. Because you see, in the real world, you probably have like lots and lots of real logic that is inside your auth providers and auth services, but we don't have all that real logic right now because our application is quite small right now. So we're going to build some fake functionality into our mock provider, and then, in our mock auth provider, and then we're going to write tests that test those scenarios. So you learn about mocking, and you also learn about writing tests for those mocks. Okay, so that's the entire purpose of this chapter. So what we're going to do then is we're going to say if, so we're going to make up an email that we don't like. We're going to say if email is foo@bar.com, then throw user not found exception. Okay, so if you're trying to log in with this email address, we're just going to say user not found. Okay. And then we say if password is foobar, we don't like the foobar password either, then we're going to say throw wrong password auth exception. So remember, login in itself, if we go to our Firebase auth provider, so go to this file, Firebase auth provider, Dart, it has those functionalities. Like if you have a look at login, it has a functionality like handling user not found, wrong password, generic auth exception. So what we're doing is that we're creating some sort of a mock of kind of the same thing, but we're locking it to specific email and password, okay? Okay, so that's for password. We don't like the email of foo@bar.com, and we don't like the password of foobar. Now, we're also going to remove the unimplemented error here. Now, in this case, let's just create a user. So we're going to say user is an auth user and is email verified. We just say true, or let's just say false, actually. So we say when you're trying to log in, we're just saying is email verified false, okay? Now that we've created a user, let's assign it to our user like this, because remember we have a private field called underscore user, and we just keep hold of it like this. And then we will do, because remember we need to return a future of that auth user, then we say return future of a value equal to our user like this. Okay. So that's our login function. So that was quite a lot of work, but I think you hopefully understand what we did right there. Now we have to look at a logout function, and the logout function is going to have some code as well. So it's not just going to be saying, okay, I logged out. As I mentioned before, we need to make sure that the mock provider is initialized. So let's bring that code in here. Boom. Okay. And we also need to make sure if you want to log out that you've actually logged in before. So let's just say if I can find my keys, if user is null, then throw user not found auth exception. Okay. Otherwise, what we're going to do is we're just going to await. So let's find an await code from before. We're just going to fake waiting a little bit, just 1 second. Okay. And we're going to set our user as well to null. We're just going to say the current user then is null. You can see it's complaining that we're using await, but let me just say in here then async. Just like that, then the error goes away, because if you mark your logout function as async, then you can await on a future. So easy as well. Logout says, am I initialized? And in order for me to log out, there needs to be a user. And then I'm going to fake waiting 1 second, and then I'm going to set that user to null. So easy peasy, okay? Now let's mock our email verification code. So same thing. So you should now be familiar with this. Let's just make sure that we're initialized. I'm going to grab a code from there. Remove the throw unimplemented error. Actually, let's leave it there. Okay, for now at least. And then during the send email verification, what we're going to do is, you see, when we did a login, we said that let's have a look at the login. We said by default the user's email verification is false, but upon doing a send email verification, we're just going to flip that flag. We're all of a sudden going to say, oh, now all of a sudden you're email verified, which isn't so realistic, but that's the logic that we're mocking right now. Okay, and remember, an auth user here has and is email verified. It's read only, like it's a constant. You cannot change it. So just because we have an optional user in our mock auth provider, it doesn't mean that we can just go and say auth user is email verified true. We can't write to it. So we need to rewrite this entire user, okay? So after checking that you're initialized, what we're doing is saying that if, let's get the user actually, final user is this. Let's get your current user. Then we say if user is null, and throw user not found. So our send email verification code is making sure that you've logged in before you can send an email verification, or at least you register your user, okay? Okay. Then what we're going to do is to create a new user. We're saying new user is an auth user and is email verified is true this time. And then we set that as our current user. So we say the current user is the new user. And then we just remove that and we make our code async as well. Okay, so that's for send email verification. So you see, it did take a while, but we've actually written now a mock auth provider that has its own code and it has its own initialization, etc. Okay, now what we need to do is to talk actually about tests. So let's see. Yes. So what are test groups and what are tests? You see, if you think of tests as, or at least unit tests, as pieces of code that test other pieces of code, you may think, okay, I'm going to write a test for create user. Here, I'm going to then write a test for current user. I'm going to write a test for initialize, login, blah, blah, blah. Now, all of these are kind of in a group. They're kind of related. They're all testing mock auth provider. And that's what test groups are for. In your test functions in Flutter, in your test suites in Flutter, you can actually group your test functionalities into a group that has a name. And then you can ask Flutter to run that entire group of tests for you. So that's what test groups are for. So now what we need to do is to go into our main test function right there and basically create a group and then a provider inside that. So let's just go ahead and then type group. And in here, we're just going to say mock authentication, okay? And let's go in here. The second parameter is just a function. And like that. So now you should have your code like this. So basically you created a test group and you can see Visual Studio Code is telling me that, oh, you can run this group. So we're going to put all our mock authentication tests inside this group. Okay. And as the caption says, the first thing we're going to do is we're going to create an instance of our mock auth provider. So let's go ahead and say final provider is a mock auth provider, just like that. Okay, so now we have that. So now we're getting to the juicy parts, and I'm so happy about this because we've done quite a lot of groundwork just to get to this point for this chapter. So now we're going to write our first test. So as you can see, the title says testing provider is initialized. Provider shouldn't be initialized to begin with. You see, we're starting with an assertion. We're saying that according to our implementation, the way we've implemented our mock auth provider, it should not be initialized to start with. So we're just making sure that by creating an instance of mock auth provider, it is initialized. A Boolean getter should return false. If it returns true, we're going to fail our tests. So meaning that if someone then sneakily goes into the code later and says, oh, this is true by default, then the tests are going to fail and all the developers in the team are going to be notified about that. Okay, so let's create our first test. The way to create tests in Flutter is that you start typing test, okay, and you give it a name. In this case, I'm going to say should not be initialized to begin with. Okay, so that's the name. Then you're going to provide it with a function to execute upon doing its test. And in here, you could use a function called expect. And then you say provider is initialized. It should be false to begin with. All right, so That's the first test that we wrote. So test function, then you write a name for it, then a function to be executed. And in there, you can use various flavors of the expect function. You'll see expect, there are various flavors of that. So right now, we're just expecting the isInitialize flag to be false. Okay. Now the next test that we have to do. So as the caption indicates, test logging out before initialization. The provider should throw a not initialized exception. So basically what we're saying is that according to the logout function, it shouldn't be able to log out if it's not initialized first. So we're literally testing this line of code, okay, to make sure that no one just unintentionally comments it out or unintentionally removes it saying we don't need it. All right. So let's test that functionality. So let's just say test. I'm going to look at my notes to see what I've named it there. Cannot log out if not initialized. Okay, now you know that as a second parameter to your test function, you need to provide a function. So parentheses, and then curly brackets. And in here, we're just going to say expect. And now we're using a new flavor of this expect. And in here, I'm just going to say provider log out. And upon calling this log out function, we actually want to expect an exception. So there is a really good catch that you can use in here. It's called throws A, and you can see throws A is a matcher, and it matches the result of the logout function against whatever you provide here. So you say throws A, and then you expect an exception in here. You say const type matcher. Type matcher is just going to say not initialized exception. So I'm going to type this, and then I'm going to show you what I'm doing basically in here. See what I've done, throws a const blah blah blah. That looks fine as well. And let's see why type matcher is not extract method const throws. I probably messed up something in here. Yeah. So let's see what is happening here. So what we're telling expect in here is saying that execute the logout function, and we're now testing the result of that function against something called a matcher. A matcher is, because you see in here, you can't say that this result should be an exception, because what are you going to do? Are you going to create an instance of that exception? That's not a good way of testing your functionality. In here, you're saying you're matching the result of calling the logout function against that expected type. As you can see, type matcher is, if you go into it, you can see is a matcher. Okay, so that's how you would expect a function to throw an exception. All right. All right, a lot of information. Now what we need to do after testing that functionality, we just need to make sure that we can actually initialize our mock provider. I'm going to bring the code a little bit up here so you can see it better. So now let's go in here and say test. And let me see, should be able to be initialized, should be able to be initialized, and create an empty function in here. Then what we're going to do is just to say await provider dot initialize like this. And remember, just like everywhere in your Dart code, you can make your functions asynchronous just by putting async right before the curly brackets. So it's not a part of the signature of the function. It's just telling Dart that inside this function, I'm going to execute some code asynchronously, okay? So upon initializing, we then, after initialize, if you look at the code that we did for initialize, it just does an await of 1 second, and then it sets the flag of is initialized true, and we can read that flag by reading this boolean getter. So let's then say await provider initialize, and then we're going to say expect the provider is initialized flag to be true after this. All right, so that one was an easy one. So after we've done all of this, you see is initialize, and doing initialization is not actually going to create a user for us. So let's make sure upon initializing our provider that the user is null. So let's just say test user should be null after initialization. Okay, empty function, and then let's just expect the user, the current user, to be null. So let's say expect provider, current user, that it should be null. All right. So easy to read, and it's almost like reading English. So, so that's it. All right. Now what we're going to do is doing some asynchronous testing. I want you to see this as well because it's very important. Now, let's say that we want to test, as the caption is telling you, testing the time required to initialize. We can test timeouts in this case. So what we're going to do is look at our initialization code here. Let's see. The initialize function here at the moment is waiting 1 second. What we're going to do in our test, just for the sake of you seeing how you can test timeouts and how you can test, for instance, API calls in the future, we're going to do some asynchronous testing in here with a timeout, saying that our test should fail if initialize on our provider takes more than X amount of seconds. All right. So now let's go in here and say test should be able to initialize in less than 2 seconds. Okay, and an empty function, which is asynchronous, just like that. Empty body for now. And what we're going to do in here is to say await on the provider's initialization. Okay. And after initialization, we're also going to expect the isInitialize flag to be true, just like that. However, we're going to use a new parameter of our test called timeout. Now, timeout, you'll provide a constant timeout to it with a duration. So a duration, and in this case, we're just going to say 2 seconds. And I think we have one extra parameter in here, const duration timeout. Argument 0 expected, but 1 found, const time, and then here seconds, and avoid const here. Okay, so this is very simply said. We're saying that we're created a test that calls the initialize function on our provider and just ensures that that function returns to the test context before the timeout has passed. So internally, this test function, which you provided a timeout to, is going to create a little timer, and then it's going to set the timer to start with as soon as it calls the function. This function in here, let me show you here. This, as that is progressing and doing its work, it's going to terminate its result processing as soon as the timeout basically passes. So in this case, our initialize function is going to take 1 second to process its work. If it can't do that during these 2 seconds of timeout, that test is going to fail. Okay, so now you know how to test that as well. So let's go in here and now test the meatiest part of our provider, which is creating a user. And as you can see, we have to test, make sure that creating a user actually delegates to our login function. And we have to test all the edge cases, all right? So let's go ahead and do that. Let's then say we test create user should delegate delegate to login function. And in here, we're going to create a function, which is an asynchronous function. All right. And what we need to do is to create this. Basically, if you remember, create user doesn't have internal logic of its own. It's just going to call login. But login has this beautiful logic that first tests foo@bar.com with any password should throw this error. User not found, auth exception. So let's just test that scenario, okay? Let's go in here and say final bad email user is provider create provider. Oh, don't we have our provider? Oh, I've added this test. I apologize. I've added this test, I believe, at the end of this entire test group. I should have added it here. So if you've made the same mistake, I apologize for that. It's my fault. You should fix that and make sure that your test is in the same group where it has access to the provider. So then I'm going to say provider. So final bad email user is provider creates user. The email is foo@bar.com, and password could just be any password. Okay, comma, semicolon, make sure Dart formatter formats your code properly. So then what we need to make sure is when the bad user is basically returned to us, then it should actually contain a user not found auth exception. So let's go ahead and say expect bad email user to actually be of should throw a const type matcher of user not found auth exception like this. Okay, let's see. And I have to close that here as well. So we're basically saying calling the bad email user, the creation of a user with that specific email should throw a user not found auth exception. And remember, you may think, oh, we've tested this before. Yeah, but that was in the context of here. Let's see. Actually, no, we haven't tested that before. It's this thing that we've tested. So sorry about that. So we've tested a lot. Yeah, we haven't tested this particular case. So all right. So now we've tested that. Now let's test this scenario with a bad password, a password of foobar. You see, we have that logic in our mock provider here for the login function. Let's test this scenario now. Let's test this code. We should throw the wrong password auth exception. Okay. So let's go in here and say final. I can see that you can't see the code. So bad password user is provider, create user with the email of, let's just say someone@bar.com, and the password is foobar, and that's the password we didn't like. Remember that, okay? Now we copy the code from here, and then we say the bad password user should throw an exception called wrong password auth exception, okay? So we've tested that scenario as well. Now we actually should test the positive scenario. So let's go ahead and say final user is await provider, and we say create user. All right, and the email is going to be foo, and the password is going to be bar. Remember, our mock auth provider is not actually testing whether an email is correct email or not. Firebase is doing that, but our mock provider isn't doing that. So we could just provide any email, foo and password of bar, and it will just accept it as long as it's not, the password isn't foo bar, and as long as the email is not foo@bar.com. Okay. All right. Now let's make sure that this user is then being assigned to the current user of our auth provider. Okay. So let's expect the auth provider. The provider's current user to actually be equal to this user, okay? Because that's what we did in our create user. Remember, we create user delegates this work to the login, and then login internally sets the current user to that user that it just created, okay? So that's the scenario now we're testing with this line of code here. All right, so that's that. So what we need to do then is just to make sure by just creating a user, which we're doing here, that the is email verified functionality, the is email verified parameter of our auth user is set to false by default. Remember, a login function here is set is email verified false. Let's test that functionality. Okay, so we just say expect the users is email verified to be false. All right. Wow, that was a lot of code, to be honest with you. And I hope that you got everything that I mentioned here. So now that we've done that, let's test the email verification functionality. And let's have a look at what we actually did in email verification. You can see we have this functionality not initialized. Then we take the current user. If the current user is null, then we say user not found exception. And then we create a new user with the is email verified to true. And we're then setting that user as the current user. So that's what the send email verification code is doing. Okay. Now you see when Flutter then runs our code, it's going to run them sequentially. So it's just going to go from top to bottom. And then you remember, before we test the email verification, we're actually testing create user, which in turn calls the login function. So since we're keeping a hold of our provider, this create user calling login function ensures that the current user actually set and is not email verified. So we can count on that. Okay. So let's say that we test. We say logged in user should be able to get verified. Logged in user should be able to get verified. Okay, and then an empty function in here. like that. So in here, we then say provider send email verification. Okay. And we say final user is provider's user, current user, like that. And we now make sure that this current user is not null. So we say expect user is not, expect the user is not null, which, as you can see, is a great matcher that you can match something against it. So you say it shouldn't be null, okay, like that. All right. And then we need to make sure that this user's verification is set. So is email verified should be true. Then we say expect, and we'll get an error now. You'll see user is email verified. It should be true. Okay, and you can see you get an error here saying that a user is optional, but we're gonna do an asterisk here saying that force on rapid for us. Okay. Now, what we should do as the last test, as the caption says, test logging out and logging in. This is normal scenario that should just work. Let's create a test for it. So let's just say test. And we're going to call it should be able to log out and log in again. Should be able to log out and log in again. Okay. And an async function. So, and a semicolon at the end. So what we're going to do here then is just to say, log out and log in, and then we get the current user and we just make sure that you're not null. So let's say await on the provider to log out, and we say await on the provider to log in with an email of just user and password, just like that. Okay, so or just email like that, because we're not actually validating the email and password in our auth provider, in our mock auth provider. And then we're going to get the current user. So we say final user is provider, current user, and we just make sure that that user is not null. So let's just say expect the user is not null. Which is a measure built into Flutter tests. All right, that was a lot of work, and I'm proud of you for sticking with this chapter. We talked a lot about tests. There's so much that you need to go through, so much material, and you need to learn on your own as well about different types of matchers and different flavors of expect. And talking about expect, I kind of expect you to go and read these things also on your own and learn about them in your own time as well. Now, the exciting part, we need to run our test. So let me change the screen layout and let's go in our terminal here and let's increase the size and let's then break this. And as you can see, you can tell Flutter to run your test by saying Flutter test and providing the path to your test. So now Flutter is going to go ahead and issue and go through those tests one by one. And let's see what we get as the result. And you can see it's giving like time for all of these tests, and it says all tests passed. Now, I just want to highlight this before we go on. We did a lot of tests. I've prepared these tests manually, so to make sure that they actually testing important functionality inside our auth provider. However, I've written the tests very carefully to make sure that they work. This is not the case when you're doing things in real life. Your tests should fail. If you've done things right, your tests should fail to begin with, and you then need to go and write your and fix your logic. If you're doing things even more right, you should write your tests first. Nothing is going to work. Then you should go and write your logic to fit those tests and expectations. So just because these tests are passing right now, I know we have joy inside. We say, oh, everything's passing, everything's great. But in reality, that's not going to be the case usually, okay? So a lot of work we did. Let's do as we usually do. Keep the tradition and let's commit our work and also tag it. So let's then say git status to see the status. Lots of things changed. Git add, git status. All right, and we're going to commit this as step 10. And then we're going to say in here git push. It's going to push our commit to GitHub. And then we git tag as well as step 10 and push tags like that. About traditions, as it is tradition in this Flutter course, we always talk about what we're going to do in the next chapter before we wrap up the current chapter. So as you can see, the caption said, let's get ready for the next chapter. We need a database to store user notes before we use Firebase for storage. Now, you see, at the moment, we're not actually writing anything anywhere. There are no notes. The user can't even create new notes. But what if we wanted to give the ability for the user to create new notes and then delete those notes and update those notes? And to begin with, we're going to store these notes in a local database inside the application. So you will learn in the next chapter about SQLite and local databases and how to use them with Firebase. And how to use them in Flutter. In the latest chapters, in the later chapters, we will change that logic. So we won't use SQLite. But I believe for any developer, if you're like I can't say any developer, but if you're a front-end developer or a back-end developer, you should be comfortable with databases. And that's exactly what we're going to do in the next chapter. So grab some refreshments and I'll see you in the next chapter.